All right, so for today's lesson, again, we're starting a new unit. Our new unit is still on ratios and proportions, but it's covering what we call scale drawings and scale factors. So when we're talking about a scale drawing of something, if we're taking a look, when you're looking at a picture, or when you guys are trying to put a picture into one of your presentations, right, you guys have done a lot of those presentations the past couple of months with your PBLs. When you copy and paste a picture in and you're like, ooh, I really want that picture to be smaller, where do you think you need to click on the picture in order to make the picture smaller or make the picture bigger without distorting the picture? Meaning that it doesn't make the picture look stretched weirdly. Where would we pull? Would we pull from the top and pull up? Would we pull from the side? Or would we pull from a corner? A corner, right? By pulling from a corner, it stretches or it changes the size of not only from left to right, but also from top to bottom, right? It proportionally is going to change the size of the picture so that the picture doesn't look distorted. It still keeps its orientation. It just changes the size. The shape never should change. The size is the only thing that changes. And it has to change proportionally. So based off of that, if this is our original picture, and these are some scaled copies, or just copies, I can't say scaled, but these are copies of that picture, which copies up here are considered to be scaled copies? Okay, and by scaled copies, I mean it has not been distorted. It is not too tall or too short or too, stretched too wide or pulled too thin or, tilted. I want to know which one of these is considered to be pretty much exact replicas, just a different size. Now, going through each of these, you're going to say either yes, it's a scaled copy, or no, it's not a scaled copy. If you're saying it is not a scaled copy, then what I want you to do is tell me why is it not a scaled copy. Was it stretched tall? Was it stretched too wide? Okay, was it changed its shape? That kind of thing. So go ahead and take a moment. Look through each of these pictures, tell me yes, it's a scaled copy or not, and why is it not. Okay, for copy A, is that a scaled copy, yes or no? No. Why is it not a scaled copy? Go ahead. It's too tall, right? This is not considered a scaled copy because it's too tall. So we would put down no, and the reason for it, it's too tall. Right? What about for B? For B, is B a scaled copy, yes or no? Don't shake your head, say yes or no. No, it's not. Who can tell me why? Why is B not a scaled copy? It's too wide, right? So no, this one's just too wide. Okay, you stretched it just long way instead of pulling it in the corner. What about C? Is C a scaled copy, yes or no? Yes. Yes, it's a scaled copy. What about D? Scaled copy, yes or no? Yes. And what about E? Scaled copy, yes or no? No, okay. So that's a no. Why? Why is it not a scaled copy? What's wrong with it, Daniel? It's tilted. Right? It's slanted. It didn't keep its original shape. Its original form was an exact rectangle, whereas this one is kind of slanted, so it's more parallelogram. Okay? All right, so let's take a look here with our scale drawings. Like I said before, it has to be proportional. Okay, so it has to keep its shape, and it has to keep its proportionality. Okay? So taking a look here, if this first F that we're seeing is considered to be our original shape, our original, I want to know what 3 shapes of F would be considered scaled copies. Okay, which 3 Fs are considered scaled copies? So we have drawing 1, 2, 3, and then on the bottom row we've got 4, 5, 6, and 7. Only 3 of them are actual scaled replicas of the original. I want you guys to tell me which ones do you think are the scaled copies. Okay, so let's go through each of these. So our original is the first F. What about drawing 1? Do you think drawing 1 is a scaled copy, yes or no? Yes, okay. So I'm going to put a check mark, yes. Drawing 1 is considered to be a scaled copy. What about drawing 2? Is drawing 2 a scaled copy? You think so? Okay, so we'll put a check mark there. What about drawing 3? Do we think drawing 3 is a scaled copy? No? Okay, yeah, too stretched, right? All right, what about 4? No, slanted. What about 5? Yes? Okay, we'll put a check mark there. What about 6? No, right? Because it lines up here. Look at those two lines for the F. It lines up, whereas do they line up for the original? No, so that's not going to work. What about 7? Yes? Okay. So now I told you guys, though, there's only 3 of them that are scaled copies. So let's figure out which one is not the true scaled copy. In fact, I'm going to tell you right now, that's not the true scaled copy. Okay, and I'm going to show you why that's not considered to be the scaled copy. Go ahead and turn it on over to the back. So on the back, I've written down that drawings 1, drawing 2, and drawing 7 are our actual scales. Right below that, we're going to go ahead and put down drawing 5 because I'm going to show you by us checking these dimensions here. Okay. So what we're going to do is we are going to count the measurements for each of the lines from the original. Okay, so we're going to first count the vertical measurement. Then we're going to count the top horizontal measurement. Then we'll count the shorter horizontal measurement. And we're going to see how it can create what we call a scale factor. Okay, and the scale factor is what we multiply the original value by in order to get to our newest measurements. So let's start first with the original shape. We're going to count the vertical. So who can tell me how many units, square units, tall is the vertical line for our original F? Van? 4, right? If we count, that's 1, 2, 3, 4 boxes that it's going to take for us to get up there. Okay, now we're going to do our top horizontal line. Who can tell me how many boxes represents the horizontal top line? Amina? 2. Okay, then we have our horizontal shorter line, our middle line. How many boxes is that middle line going to be? Daniel? 1. Okay, so these are our original dimensions, our original values for the value of F. Now we're going to go ahead and do the same thing for drawing number 1. We're going to count how many boxes each of these takes up. So when we're doing our vertical line for shape 1, for drawing 1, how many boxes tall is that vertical line going to be? 6, right? What about the top horizontal line? How many boxes long is that? 3. And then for the horizontal middle line, how much is that going to be? Say it again. 1.5, right? It covers one whole box and then half of a box. So it's 1.5 for that one. Okay. So now my scale factor, I want to know what times 4 will get me to 6. 2 times what will get me 3. 1 times what will get me 1.5. So my scale factor in this case happens to be 1.5. If I multiply 4 times 1.5, that gets me 6. 2 times 1.5 gives me 3, and 1 times 1.5 gives me 1.5. A really easy way to be able to identify your scale factor, just so you guys know, is you're going to take whatever your newer drawing is, whatever your scale drawing is, and you're going to divide it by your original drawing, your old drawing. Okay, so if you take the new measurements, this is considered new, and you divide it by the old, you'll get your scale factor. So 6 divided by 4 is 1.5. 3 divided by 2 is 1.5. 1.5 divided by 1 is 1.5. Okay, I want you guys to go ahead and do that for problem 2 and problem 7. You're going to tell me what each of the measurements are, and then you're going to tell me what the scale factor was to go from your drawing, or from your original to your drawing. All right, so for drawing 2, guys, what was the vertical height for drawing 2? 8. Okay, what was the top horizontal measurement? 4. Okay, and what was the middle horizontal measurement? 2. Okay, so then who can tell me what was the scale factor, the original to the drawing number 2, what was the scale factor going to be? Come on, take your new measurements and divide them by the old measurements. What would that give us, Daniel? 2, right? 8 divided by 4. 4 divided by 2. 2 divided by 1. That gives you a measurement of 2. Your scale factor is 2. So that means that drawing number 2 is 2 times bigger than the original. It's 2 times bigger. Okay, what about drawing 7? What is the vertical for drawing 7? 12. Okay, what is the top horizontal? 6. And what is the middle horizontal? 3. Okay, so then what is the scale factor going to be? 3, right? If you do 12 divided by 4, if you do 6 divided by 2, if you do 3 divided by 1, you're going to get 3. So now, let me show you why drawing 5 is not considered to be an actual scale drawing. So if we take a look at drawing 5, the horizontal count, who can tell me what the horizontal count is for drawing 5? Go back to your drawing 5, look at the horizontal count. What is that going to be? 6, right? So I'm going to put a 6 down here. What about the top horizontal? 3. Okay, and then what about the middle horizontal? How big was that? 2. Right? So if we're taking a look here for drawing 5, if we did 6 divided by 4, that would give us 1.5. If we do 3 divided by 2, that would give us 1.5. But then when we get to the shorter horizontal, we do 2 divided by 1, that gives us 2. Those are not considered to be equal. Remember, proportionality means it all has to be equal. Those are not equal. Therefore, this is not considered to be a scaled copy. It looks close to it, right? It looked very, very close to being a scaled copy. But we can't always base things off of what they look like. You have to base it off of the actual numbers, okay? Now, we can create scaled copies as well by multiplying by scale factors. So we're going to go ahead and pick another scale factor. So we already had a 1.5, we had a 2, we had a 3. Let's pick another number. I'd say keep it under 5 though, because if we try to do a scale factor of 5 or greater, it won't fit on this picture. So pick a number somewhere between 1.5 and 5. 4? Okay. So we're going to use a scale factor of 4. If I use a scale factor of 4, that means what I'm going to do is I'm going to take this 4 and I'm going to multiply it by 4, and that's going to give me my new measurement. What's 4 times 4? 16, right? I'm going to take this original value of 2 and I'm going to multiply it by the scale factor of 4. And that's going to give me now a measurement of what? 8, right? 2 times 4 is 8. Then I'm going to take this original value of 1, and I'm going to multiply it by that scale factor of 4, and it gives me a new measurement of 4. So these are my new measurements for drawing a value for f. So I'm going to go 16 units vertically. So that means we're going to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 16 units for my vertical. Starting at the very top, we're going to have to do 8 units across. 1, 2, 3, 4, 5, 6, 7, 8. And then in the middle, it's going to be in the middle of my vertical line is where I'm going to create my next horizontal line. So what's in the middle of 16? 8. So I'm going to have to go down 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to draw my 4 units over. 1, 2, 3, 4. Okay, there's my new scaled drawing for F by going 4 times bigger. Now, notice that every time we multiply, it gets bigger, but sometimes when we multiply, it gets smaller. If your scale factor is less than 1, then it's going to shrink your item down. So let's do another one. We're going to create one that has a scale factor that is less than 1. So let's go with 0.5. We're going to go with a scale factor of 0.5. So if I were to multiply each of these by 0.5, so that means I'm going to take the 4, the original 4, and I'm going to multiply it by 0.5. Then that's going to give me a value of 2. If I take my original value of 2 and I multiply it by 0.5, that's going to give me a new measurement of 1. And if I take my original measurement of 1 and I multiply it by 0.5, then that's going to give me a measurement of 0.5. Okay, so now I can draw that, and it's going to create a scale drawing that's smaller than the original. So again, I have a height of 2, and I'll just do it right below it. A height of 2, a vertical line that is just 1, and then a horizontal line that is just a half. And there's a smaller scaled replica of my original. Okay, so scale factors that are bigger than 1 will enlarge your item. Scale factors that are smaller than 1 will shrink your item. Okay, so based off of that information, I want you to go ahead and, again, one more time, we're going to identify if A is our original, then which one of these is the scaled copy of A? Is it going to be B, C, or D? And then tell me what the scale factor is. Which one's the scaled copy and what is its scale factor? Okay, so going over this one, if the original was A, which one of these is considered to be the scaled copy? B, C, or D? Which one do you think, Amna? C. C is going to be our scaled copy. Let's take a look as to why. So we have several different measurements that we can find that are in common. So we have a vertical measurement. If we look at A happens to have a vertical measurement that is 1, 2, 3, 4, 5. And C happens to have a vertical measurement that is 10. So if we take 10 and divide it by 5, that's going to give us a scale factor of 2. Okay, if we pick another measurement on here, let's take a look at this top measurement. This top measurement is a box of 1, whereas for C, it's a box of 2. Again, if we take 2 and divide it by the 1, that's going to give us 2. If we do, we'll take a look at this bottom measurement here and measuring these out. So for this bottom measurement, we've got a value of 3, and this bottom measurement is a value of 6. If we take 6 and divide it by 3, it's going to give us a measurement of 2. Okay, and we could keep doing it and checking all of the sides. They all would happen to come out to where we've got a scale factor of 2, whereas these shapes do not have any proportional scale factors that are consistent throughout. Okay, so again, as a reminder, all you're going to be doing today is identifying your scale factors. So your scale factor, once again, is just taking your new measurements, which we call a scaled copy or our scale drawing, and we're going to divide it by our original. or our older measurement. Whatever is original drawing. Okay, you take the new and you divide it by the old. Take the new, divide it by the original. That's all you're going to be doing today. If you log in to Google Classroom, you're going to see a Delta Math assignment that's been loaded in there. Go ahead and get it started. Remember, it is due tomorrow. Whatever you don't finish is marked wrong. So if you only get 40% of it completed, you get a 40 for your grade, and that will not change. Okay?